Hello class, welcome to Algebra Lesson 1-3, which is all about weighted averages. By the end of this lesson, you should be able to solve mixture problems and uniform motion problems using weighted averages. You might be thinking to yourself, we've already watched a Lesson 1-3 video, and you are correct. Way to pay attention. 1-3 that you've already watched a video for, that was strictly the solving equations. Today we're going to talk about weighted averages. And tomorrow, it's still Lesson 1-3, and we're talking about something called dimensional analysis. So yes, Lesson 1-3 is split up into multiple days, multiple videos, so you're not going crazy. Well, you might be, I don't know, but not going crazy considering that there's 3 lessons. Example 1, weighted averages have to do with a lot of things that when you guys are given these problems, in the past you've always had to do kind of like a guess and check until you found the correct answer. Now I'm going to show you the fancy way to solve these problems. So, at the Golden Oldies Theater, tickets for adults cost $5.50 and tickets for children cost $3.50. How many of each kind of ticket was purchased if 21 tickets were bought for $83.50? So the way that we solve this problem is, you can see there's a table there. And I'm going to teach you how to solve this using a table. In the first column, we write down our items. So we have adult tickets. We also have children tickets, right? Wow, if I could spell children. The struggle is real today, you guys. Children tickets. And then we have the total number of tickets. Okay, so you start with your items. Then let's talk about the amount of tickets, because we want to know how many of each were purchased, right? And the cost, right? The price. And then in the last column, that would be our total in cost, right? So we know, what about adult tickets? We know that they're $5.50. We also know that children tickets are $3.50. We know that there were 21 tickets purchased, so I would put that in this column right here. And I know the grand total that was paid was $83.50. So now let's go through and figure out, how do we fill in these other boxes? So do we know how many adult tickets were sold? No, because if we did, I wouldn't be asking this question, right? So I'm going to write X there, because we use variables when we don't know what something is. Then how would I figure out the total number of children tickets? Some of you might say, let's use Y, or another variable, but how about instead of using another variable, because then we don't know how to solve that yet. We haven't practiced solving equations where we have 2 different variables. So instead, what we're going to do is we're still going to use that X, but instead I'm going to take the total number of tickets that were sold, so 21, and I subtract the number of adult tickets that were sold, which was X. Okay, so we didn't know how many adult tickets were sold, so we put X. We don't know how many children tickets were sold, so I take the grand total number of tickets sold, and I subtract the number of adult tickets in order to find the number of children tickets. Then, the way I would find the total price for adult tickets is I would take $5.50, multiply it by however many adult tickets were purchased, and in order to figure out the total cost of children tickets, I would do $3.50 times however many children's tickets were sold. Once your table is set up, that tends to be like the trickiest part of this whole process. Now this final column here is your best friend. This is where you get your equation from. You add the top 2 boxes and set it equal to the bottom. As long as you put the bottom, or the bottom row is your mixture or your total of your combination, as long as you do that, this system always works, where you add the top 2 and set it equal to the bottom. So now if I write that out as an equation, I would write 5.50x, or you could write 5.5, that's fine. I'm going to keep the 0 there because we're talking about money, plus 350 times 21 minus x equals 83.50. Now from there, I can start simplifying just like we practiced yesterday. And so 350 times 21 gives me 7350 minus 350x equals 8350. If I combine my x's, I have 2x plus 7350 equals 8350. And then I subtract my 7350 from both sides. And I am left with 2x equals 10. Divide both sides by 2, and I get x equals 5. Now if I go back to my table, what did x represent? X represented the number of adult tickets. So we know 5 adult tickets were purchased. And then if I asked how many children tickets were sold, you would do 21 minus 5, or you would know that that is 16 children tickets. And that would be your final answer. So instead of doing the guess and check method until you are incredibly frustrated and don't know what else to do, now you know the method to solve it using a table. And like I said, these can be very, very frustrating. So if you're looking at this and you are feeling like, oh my gosh, Ms. Johnson, I'm never ever going to know this, that's a lie. You'll figure it out. Maybe not right away on this first problem, but if you keep trying, you can do it, I promise. We're going to do another example that's kind of like this, okay? So this time we're talking about a chemistry experiment, and I promise you when you get to chemistry in high school, you get to do problems like this. So if you learn it now, it's one less thing to learn in high school, okay? So we have a chemistry experiment calls for a 30% copper sulfate solution. Bob has 40 milliliters of a 25% solution, so something that's a little weaker. And then how many milliliters of a 60% solution, so a much stronger solution, should he add in order to obtain the 30% copper sulfate solution? Okay, so we have the 25% copper solution. We have the 60% copper solution, but what we want is the 30% copper solution. If you're unsure which one should go on the bottom, or what order to put these in, let me tell you, these top two don't matter what order you put them in. You could put 60 on top and 25 on bottom, or you could write it the way I did. The only one that really matters is that when you have these problems that have percentages, whatever number's in the middle needs to go on the bottom. Like 25 would be between, or sorry, not 25, 30 is between 25 and 60, right? You have the weakest listed up here, you have the strongest listed up here, and you have the one in the middle listed at the bottom. So that's how you set up this very first column. Okay, and this is our copper sulfate. Okay, and then we want to know the milliliter situation. And whenever you have percentages, one of your columns is your percentage as a decimal. Okay? That's every time. Anytime you have a problem that has percentages, the percentages as a decimal is one of the columns. Then the very last column is the concentration. So whatever they are left with. All right, so for the 25% copper sulfate solution, we know that Bob has 40 milliliters of that. And we want to know how many milliliters of a 60% solution is needed for making the 30% copper solution. Now, does it tell us anywhere how much of the copper solution we need? No. So what you do is you take however many milliliters of the 25% plus however many milliliters of the 60% solution. So we would have 40 plus X for 30% copper solution. Then the percentage as a decimal is as easy as converting 25% to 0.25. 60% becomes 0.60, and 30% becomes 0.30. Now your last column, this column, which I forgot to mention this on the last slide, is made by multiplying across. So 40 times 0.25, x times 0.60, and 40 plus x times 0.3. Then just like on the last one, add the top two, set it equal to the bottom. So 40 times 0.25 is just 10, plus 0.6x equals 0.3 times 40 is 12, plus 0.3x, once you've distributed right there. And then it's just solving like normal. So I can subtract that 0.3x from both sides. And I have 10 plus 0.3x equals 12. Subtract 10 from both sides. 0.3x equals 2. And just because I ran out of room and don't feel like scrolling down, I'm going to copy that. 0.3x equals 2. I would divide both sides by 0.3. And I get x equals 6.66 milliliters. So if we go back to the problem, it says how many milliliters of a 60% solution should he add to obtain the 30% copper sulfate solution? X represents the amount of the 60% solution. So this is my final answer. I know I need 6.66 milliliters of the 60% copper solution in order to solve this, or in order to make this mixture. If you have questions on that, please ask for some help. We are going to practice these, I promise. Example 3. Again, we have a table. Yay! Right? Or you might be rolling your eyes at the screen. I get it. Example 3. Sam is investing a total of $12,000 in 2 accounts. Part of his investment is at a 4.5% interest rate, and the remainder is at a 6% interest rate. If the total amount of interest earned from the 2 accounts is $637.50, how much did Sam deposit in each account? So again, you start by listing your items. So in this case, we have a 4.5% account. We have a 6% account. And this time, we just have a total between the 2 accounts, right? The total money. So I want to know how much he invested into each account. And I know the interest rates. And then this last column would be, wow, I just cannot spell today. The last column is how much interest he has earned. So starting with the easiest stuff, the interest rate, you just start by converting to decimals. Okay, that's easy enough. And since these are 2 separate accounts, there's no like mixed account or anything. So I actually don't need that bottom box. Then I know the total money he deposited was $12,000. But I don't know how much he put into the 4.5% account, nor do I know how much he put into the 6% account, because again, if I did, we'd be done with this problem. So then for the 6%, you take the total and you subtract however much was in the 4.5% account. Then just like before, you multiply across. So we have 0.045x. I have 0.06 times 12,000 minus x. And then we know the total amount of interest earned was $637.50. So again, I take my top 2, add them, and set it equal to the bottom. So I have 0.045x plus 0.06 times 12,000 minus x equals 637.50. If I simplify that a little bit, I have 0.045x plus 720 minus 0.06x equals 637.50. Again, I can simplify more because I can combine my x's, and I get negative 0.15x. And I can say plus 720 equals 637.50. Subtract 720 from both sides. I get negative 0.15x equals negative 82.50. Divide both sides by negative 0.15. Divide by negative 0.15. You get x equals 5,500. And that means I need to go back and look at my table to figure out what does x represent. It represents how much is at the 4.5% interest rate. So I can say $5,500 was invested at the 4.5% interest rate. And then what I would do is I would say 12,000 minus 5,500 is $6,500 was invested at the 6% interest rate. And those would be the two starting amounts in each account. Hopefully you're starting to see the patterns of setting up these tables. As I've said multiple times in this video, be sure to ask for help if you need it, okay? Example 4 is a little bit different than everything that we've talked about so far in this video. You can see that we still have a table. It's slightly smaller, so it's the same kind of idea. But whenever we deal with distance problems, you set it up a little differently. So I'm going to remind you that if I wanted to figure out the total distance traveled, I would take however fast something's traveling, so the rate of something, and I would multiply it by however long it's been traveling. So distance equals rate times time. Okay, now with that information, let's read the problem. 2 trains leave Minneapolis at the same time, one traveling north and the other traveling south. The first travels at 75 miles per hour, while the second goes at 60 miles per hour. How long will it be until the 2 trains are 500 miles apart from each other? So we have our first train, so we'll call this one the north. And then we have our second train, we'll call this one the south. And we know their rates, right? We're told how fast they're traveling. So the train traveling north is traveling at 75 miles per hour. The train traveling south is traveling at 60 miles per hour. And we want to know the time it takes for them to travel apart from each other. Travel in order to be 500 miles apart from each other. So you always do rate, then you do time, and the last column is always your distance. Okay? We don't know how long these trains have been traveling, so I'm going to use a t for both of them. The reason I'm going to use a t for both of them rather than like t minus something is because if we're trying to figure out how long it will be before they are 500 miles apart from each other, that's going to happen at the same exact time for each train. So you use the same variable. And then in order to figure out distance, I would do 75t, right? 75 times t, because distance is rate times time. And then I would do 60t. Now the last thing we know, we haven't used anything with the 500 miles apart from each other. We know that these 2 items have to ultimately be set equal to 500 miles, right? So what I'm going to do is I'm going to add the distances of the 2 trains, in order to figure out when their distances amount to 500. So then I have 75t plus 60t, which is 135t, equals 500. Then if I divide both sides by 135, I get t equals 3.7. So after about 3.7 hours, the trains will be 500 miles apart. And if you want to convert that 0.7 into exactly the correct number of minutes, go for it. Today I'm not going to do that. And if you need help with that, feel free to ask. I'm happy to show you how to do that if you've forgotten. But that is the last example I have for you. So on your test, I promise you, you will have one question that's similar to examples 1, 2, and 3, just one question. And then you will have one question that is similar to example 4. Okay? So if you're freaking out and thinking, oh my goodness, this is really, really tough, it is tough, but you can do it, and just make sure you ask questions. Have a good day.